Good morning, everyone. I hope you are all doing well. In this video, we're going to explain part C in chapter 1, which is homogeneous and heterogeneous mixtures. But before we start with the new ideas, let's review some ideas from the previous video. There are three basic states of matter: the solid, liquid, or the gas, and a fourth state of matter that can exist at a very high temperature, and this state is called plasma. A solid has a definite shape and volume. A liquid has a definite volume at constant temperature, but it takes the shape of the container. A gas takes the shape and volume of the container. Distilled water is a pure substance that has the same characteristics throughout, and it is made of one kind of material which does not separate into other substances by simple means. A mixture is made up of a mixture is made of two or more than one kind of material. The last point, the boiling point of a pure substance is constant while the boiling point of a mixture is variable. These ideas were mentioned in the previous videos, so please I want you to review them very well. Activity 10, classifying mixtures. The materials used here are test tubes, oil, vinegar, stirring rod, alcohol, table salt, distilled water, and iron nails. Procedure. Pour enough water into a test tube containing a few iron nails and stir. Here, in the first step, we put water in a test tube and then we put few nails and we stir. Repeat step 1 by using oil instead of iron and shake the mixture for a few minutes. Here we put water and oil and we stir the mixture for a few minutes. In another test tube, add some table salt to water and stir for a complete dissolving. In this step, we dissolve salt in water. We stir it very well to have a complete dissolving. Repeat step 3 by replacing the salt with alcohol or acetic acid. In this step, we fill a test tube with water and we add alcohol and stir very well. So here we have four mixtures. The first one is water and iron nails. The second is water and oil. The third is water and table salt. And the last, here we have water and alcohol. So here we have four mixtures with different compositions and we have different phases. So in activity 10, we obtained four different mixtures with different composition. Let's take a closer look. In the first step, we put water and nail. So here we have two layers or two phases, water plus nail. In the second one, we also have two phases, oil and water. In the third one, we have only one phase where table salt is totally dissolved in water. So here we can observe only one phase. And also in the last step, we have only one phase. Explore. How many phases are formed in the mixture of step 1 and 2? As we said, here we have two phases and also here we have two phases. So the answer is two phases. How many phases are formed in the mixture of step 3 and 4? Here we have one phase and in the last we have only one phase. So the answer is one phase. Conclude. Compare and classify the resulting mixture obtained. The mixture in step 1 and 2 is heterogeneous. since it is formed of two phases, while the mixture in step 3 and 4 is homogeneous since it is formed of one phase. So heterogeneous mixture is made up of two or more phases, while the homogeneous mixture is made up of only one phase. Homogeneous and heterogeneous. In activity 10, two different types of mixtures are prepared. The first type is made by mixing water and iron nails or oil with water. The second type is made by mixing table salt with water or alcohol with water. The first forms two phases and is called heterogeneous, while the second forms one phase and is called homogeneous. So a heterogeneous mixture is made of two or more substances forming different phases. It doesn't possess the same properties in all its parts since the distribution of particles is not uniform in the mixture. A homogeneous mixture is made of two or more substances forming only one phase. The mixture possesses the same properties in all its parts, since the particles of one component are uniformly distributed throughout the mixture. However, not all mixtures are perfectly homogeneous or heterogeneous. Other types of mixtures lie in between these two, where some mixtures may appear homogeneous, but in fact they are closer to heterogeneous mixture. For example, if we have fresh orange juice, it may appear homogeneous, but in fact this orange juice is heterogeneous. So some mixtures may appear homogeneous, but in fact they are closer to heterogeneous mixtures with respect to the non-uniform distribution of its particles. Summary. Matter exists in the three basic states, solid, liquid, or gas. Matter can be classified as mixtures and pure substances. A pure substance is formed of one kind of material having constant properties. A mixture is made of more than one kind of material having variable properties. Here we have the definition of pure substance and the definition of a mixture. Mixtures are classified as homogeneous and heterogeneous. A homogeneous mixture is made of two or more substances forming one phase and which has a uniform composition. This is the definition of the homogeneous mixture. A heterogeneous mixture is made of two or more substances forming different phases of non-uniform composition. So, as we said, homogeneous mixture forming one phase, while the heterogeneous mixture forming different phases, two or more phases. Now, let's solve exercise 8, page 23 in your book. A liquid A is heated gradually. The temperatures are recorded every minute according to the following table. Here we have a table. We have time in minutes. We have temperature in degrees Celsius. So temperature and time. Time in minutes, this is the scale, and temperature in degrees Celsius, and this is also the scale. At time 0, the temperature is 22. As time increases from 1 to 8, the temperature increases from 30 to 78. And it becomes constant after this value, right? Let's see here, the temperature is 22, increases to reach 78, and then at time 8 minutes, temperature is 78, at 9 minutes, temperature is 78, 10, 11, and 12, the temperature is also the same. So the temperature after time 10 minutes remains unchanged. Part A. Why does the temperature remain constant after 8 minutes? What does this temperature represent? Liquid A is a pure substance. How do we know that liquid A is a pure substance? Because pure substances have a specific physical constant, like the boiling point, the freezing point. So here we have the boiling point constant at 78. So liquid A is a pure substance, and this temperature is the boiling point of liquid A. Is liquid A a pure substance or a mixture? As we said, it's a pure substance because it has a constant boiling point. Liquid A is a pure substance since it has a constant boiling point. Few crystals of solid S dissolve completely in 100 cc of liquid A. Is the mixture obtained homogeneous or heterogeneous? How many phases are formed? Solid S dissolves completely. So the components are uniformly distributed throughout the mixture, right? So it is a homogeneous mixture. How many phases are formed? One phase. So liquid A is a homogeneous since the crystals dissolve completely and one phase is formed. How do you recover solid S from the above mixture? We can evaporate liquid A by heating. So in this way, we can recover solid S. Exercise 9, page 23. The three figures represent graphically the curves of temperature variation with time for three different solids, A, B, and C, with the same scale. Which of the solid substances A, B, C is or are pure? Why? Look at curve A. Here we have temperature. The temperature increases to reach T1. Then it continue increasing to reach T2 and it continue increasing after T2. Curve B, the temperature increases gradually to reach T3 and then it becomes constant for a specific period of time and then it increases. So here we have a constant temperature. In curve C, the temperature increases gradually to reach T4, then it becomes constant for a specific period of time and then it increases. So which of the solid substances is or are pure? Substance B and C, or solid B and C, because they have constant melting point. Here we have a constant melting point, which is T3 in curve B and T4 in curve C. Which of the solid substances A, B, C is or are mixtures? Why? We said that substance B and C are pure. So substance A is a mixture. A because it has a variable boiling point. The temperature varies with time. Part C. Which of the two solids A or which of the two solids B or C do you predict to have a higher boiling point? B or C have a higher boiling point? B has a higher boiling point than C. How do we know? From the curve, the temperature in B increases more than the temperature in C. What is the physical state of solid A at a temperature higher than T2? This is T2. This is solid A. After T2, what's the physical state? We said that it's melting, right? So after T2, the state will be liquid, because in melting, the solid is transformed to liquid. Exercise 10. Look around you and try to find out whether our surrounding is rich in mixtures or in pure substances. Justify. What do you think? Our surrounding is rich in mixtures because nature allows substances to come together and mix. So, our surroundings are rich in mixtures because natural processes allow substances to come together and mix together. For example, in nature there are many substances, solids, liquids, and gases. They naturally interact and forming mixtures. For example, air is a mixture of gases like oxygen, nitrogen, carbon dioxide, and other gases. Also, we have soil. Soil is a mixture of minerals, organic matter, water, etc. Also, rivers are mixtures of water, salts, minerals. So these mixtures occur because natural processes like the movement of water, movement of wind, and even biological activities encourage different substances to come together. So our surrounding is rich in mixtures.